It's great to have you at this MicroStream training. Thanks for joining. My name is Markus Kett. I'm CEO and co-founder of MicroStream. And I'd like to give you a short introduction, really short introduction, I swear, into MicroStream, the functional principle. And it's really not the same presentation I used at JCon. It's because I improve my presentations all the time to make it better. So in a nutshell, MicroStream is a Java native micro-persistence layer. So we call it micro-persistence because it's super lightweight. It's a small Java library. It has no dependencies. The only dependencies to the JDK. Through runtime, it runs within the JVM process of your app or your microservice. And it allows you to store real Java object graphs, which means we do not introduce our own database-specific data structure or format. We really use the Java object graph that is used by Java in the memory. So we use the Java memory model. With MicroStream, you're able to store your any kind of object graph, any size, any complexity. You're able to store it persistently into any file storage. Any means you're able to use plain files. So this is the obvious way to store it. But it's also because we store it in a binary format, it's also possible to store it into almost any database system, and because they're able to store binaries. So we have connectors to all major database systems, and it's also obvious to store it into a cloud blob storage like AWS S3. Vice versa, when you load the application, then you're able to load any subgraph into the memory on demand when it's needed. So it's possible to load the entire object graph into the memory, which means you would load the entire database into the memory. Basically, this is possible, but mostly you won't do that. With MicroStream, it's really possible to load single subgraphs on demand by using lazy loading. If you have enough memory, you can keep the system state in memory. You can keep your objects in memory to execute everything in memory with Java. Then it's super fast. If you have not enough memory, then you can use lazy loading, as I mentioned. When the object reference is loaded by MicroStream, then it's merged directly into your object graph, fully automatic. So you don't have to deal with object copies. Everything happens on the object graph, and your object graph becomes your in-memory database. This is great because the Java object graph is actually a multi-model data structure, because in Java we can use everything. So you can store lists, simple lists. You can use all collections, all Java types. You can add, for instance, a JSON file. You can build up your own key value store. You can create your own index. So everything is possible. Everything that is possible in Java, you can do this, and MicroStream will be able to store it. So the only thing that it's not possible to store is something that cannot be reconstructed after loading. So which, for instance, a thread. So it makes no sense to store a thread. Everything else can be stored. And this is what MicroStream does. And the concept, the philosophy is to keep everything in memory that is possible. If, of course, you should have enough memory, but it's not mandatory, as I mentioned. It's also possible to run micro machines like serverless functions, micro machine means a machine or a serverless function that is smaller than 1 CPU power and only, let's say, 256 megabytes of RAM. So it is also possible because of the possibility to use lazy loading. And so to introduce fully in-memory data processing with pure Java. And the cool thing here is that we can use core Java concept for everything. So the data structure is a Java native object graph. We don't have to invent a new query language because we can use Streams API for searching and filtering object graphs, and this is done in microseconds. So the JVM here is super fast. We can use parallel streams. This is supported by your hardware, and it's accelerated by the hardware. It's in any case super fast. The only thing that is not provided by Java is really a function that stores the object graph, and this is actually the only. This is what MicroStream does, and it's the only missing piece of puzzle. So you can include it via Maven, and so then you can use it from scratch. I have also prepared some new slides, but I don't know if this is mandatory. So just please give me a second. I have not the right presentation here. Just a second, please. What's new with MicroStream is now that we now also, or what was not possible before, MicroStream as it is a single node storage, which means you can only store the object graph of only one JVM instance. So it was not possible to build distributed applications by using MicroStream. And this is now new. Now we are able to replicate the object graph in memory, and to allow you creating distributed applications or microservices with MicroStream. Just back to the beginning. What we have done with MicroStream here is how traditional Java persistence works. Here we can see the architecture of a traditional Java application. Here is a microservice or an application, monolithic application, doesn't matter. The object graph in memory, we have a JVM, and we have a machine instance, and we have, let's say, a relational database. It's very important to understand how the database works internally. Most of you guys know it already, but sometimes we forget it. It's because, hey, we submit an SQL to a database, and a database is a black box. But here is just how it works. So please keep in mind, a database system also runs on a machine instance on its own server, and has a database management system, loads data in memory, caches data in memory, has its business logic. So most Java developers don't use it. So store procedures, so store functions. And we have a data storage where the database system stores data on disk. And we have to keep in mind, in cloud environments, we don't know where the storage actually is. So perhaps you have a database service that runs on a machine instance, but the storage is anywhere else. So if we have if we query the database, we have a network call, or we have data through a network, and perhaps we have another network call between the database machine and the storage, perhaps. So, and this is very important when we then later think about MicroStream. And as I said, what we did now is we have the problem with traditional databases is that the objects are cannot be stored in a relational database. So we need a mapping, and we have these impedance mismatches here between relational database and Java. And this is pretty much the same when we use a NoSQL database, because all of these data structures are also incompatible with Java object graphs. So this is the reason why we need an object relational mapping or a data conversion with NoSQL databases. So, and when we build distributed applications in a traditional way, so we start more and more instances of our application or our microservice, then we have the problem in terms of consistency. So because our local machines, all nodes use mostly a local cache to accelerate database query, and then if one of these nodes want to store an object into the database, the change object and store it into the database, then the system is not consistent anymore. So this is the reason why in traditional database applications we need an in-memory data grid or a distributed cache, and so we add another layer. We have to add another layer in between. So you start another cluster. For instance, you can use Redis for that, or coherence. So this is the common way to do it. And if you have much more load on the database, then you need another cluster. You need a distributed database and have to set up a database cluster. So here you run multiple multiple machines. And this is the reason why today's big data architecture applications are so expensive in the cloud. And what we did with MicroStream is, just a second. So let's go back to the simple architecture. What we did with MicroStream is, here we have our traditional database application and our traditional database system. So now we replace the data converting or the object relational mapping with MicroStream. Okay, so, and then everything is in memory because our object graph is our in-memory database. We don't need the local cache anymore. So we can remove it from our architecture. The architecture gets now much more simple. Then let's have a look at our database server. Because now the in-memory, the object graph becomes our in-memory database, the database moves from the database server to the memory. So we don't need a database on a remote machine. So we can skip it. And the database management system as well, because our business logic now becomes our database management system. And here we only have a storage. This is the reason why MicroStream architecture is much more simple. So let's go back one step. So traditional persistence, we replace Hibernate with MicroStream. or a data conversion, if you have JSON conversion with a NoSQL database. The object graph in memory is our in-memory database. We don't need a cache anymore. We don't need a cache configuration, so you can forget everything. And on a database side, we don't have a database on a remote machine anymore, because the object graph becomes a single source of truth. This is our in-memory database. So we can now skip the database on the remote machine. And the only thing we need is to store the object graph persistently on a disk. That's it. This is the reason why MicroStream is that simple from the in terms of the architecture. And now with MicroStream cluster, it's the same. So here is again the overview about traditional cluster architecture with our distributed application, distributed cache, and database cluster. Now you're able to replace your Hibernate machines or with a MicroStream machine. It needs much less hardware power. It's because everything is in memory. It's super fast, executed by the JVM, so you can handle much more loads and queries with only one JVM. It's really incredible because everything is in memory. We don't need a cache anymore. So this means we can remove the distributed cache even. And we can remove the database cluster because we don't need a database system that runs on a remote machine. So now we can replace a database cluster with only a storage, because we store binary data. As I said, we don't need a cache anymore. We don't need the cache cluster. So we can remove even the cache cluster from our architecture. And now MicroStream is able to replicate your object graph through even hundreds of JVMs, and you can cluster your MicroStream application. And then we have a super simple architecture, super easy to maintain, to develop, to deploy. It's core, everything is core Java, and this is the functional principle. In this training, we do not cover the building distributed apps or microservices, but the cool thing is it's pretty much the same. So it does not matter if you create an application or a microservice that runs on only one single JVM, or if you build a MicroStream cluster. So the API will be pretty much the same. And so also building distributed applications with MicroStream is super simple. And the cool thing here is that MicroStream cluster automatically clusters your business logic automatically. So the infrastructure is provided by MicroStream cluster, and you don't have to care about how to cluster your business logic. Yeah, all right, and everything basis on core Java, and now Rudy will explain how this works in detail, how you download it via Maven, use it in your project, build the data model. And the cool thing here is there are no restrictions, no limitations by MicroStream. So you can really create your object model completely freely, and you don't have to build your Java application around a database system that works completely different from Java. So this is much more simple, and it's extremely powerful. This you will check it out anyway. through this training. Here we see Streams API is so incredible fast. When I saw it for the first time, I could not believe it. That is so incredible fast. But actually, this is not really a surprise. It's because this is Java. This is plain Java, and so the only thing is we can use it now because we have now a possibility to store the object graphs as they are. And this is, I think, the main difference to all data storage technologies on the market, that all of these solutions use and introduce their own data structure or format. This is the biggest difference. And I don't know, the reason is, yeah, the relational databases, they were on the market decades before Java was invented. So we were used to use the relational databases, and database vendors, they mostly want to build a product that fits for all programming languages. And MicroStream was created only to run with Java, so you can use it with Java only, but with all JVM languages, of course. But it's not possible to run a C# program with MicroStream. So there are also trade-offs. Other trade-offs are you have to care for your business logic. And it's because we don't want it to invent a new database management system that cares for everything. And the reason is Java developers mostly care for the business logic. You care for locking anyway, and you care for concurrency mostly anyway. So we wanted to build a system following separation of concerns. The only thing MicroStream does is storing and loading object graphs as they are in memory, super simple and high efficient. So that's it. And everything else is provided by Java. If you miss anything in MicroStream, have a look on the Java ecosystem. There you have almost everything. So for caring for concurrency, for searching, you can use Lucene. If you have concerns of garbage collector pauses when you deal with bigger memory sizes, you can check out. Sorry, you can check out other Java virtual machines like OpenChain 9 or Azure JVM. They are able to run bigger memory sizes. To accelerate your system and to deal also with big memory sizes, because it's possible. So you can do that. So you will save tons of cloud costs by eliminating all these machines. So you can invest in more memory. But if you run microservices with super small memory sizes, then you can do that. You can scale horizontally. So that's it in a nutshell. Do you have any questions so far, or should we jump directly into code?
I see there are a few questions. Okay. They are mainly all related to what you mentioned at the more advanced thing, like clustering. Mm-hmm. So maybe I can handle those questions, but as it was mentioned, this is just the basic one. We are not going into detail on how to use a clustering, a multi-JVM setup. I'm happy to answer, of course, these questions, but we cannot go into detail because otherwise we will not get to the end of our agenda. So I can handle this.
Regarding the simple architecture, is it the case that MicroStream's binary representation is the same as the old Java object streams, or is it something new?
No, we have defined our own byte format, and we provide a CSV converter, and we are working on other converters, but it's the MicroStream format. So this is a specific byte format.
Okay, so presumably it does not suffer from the old security problems that the object stream format suffers from, right?
Correct. Yeah, I'll go into more detail that today also.
And shortly, actually, it's very simple to create your own MicroStream cluster, because we do it in the same way as everybody has to do it when you develop microservices. So there also you have multiple instances of a service. If data change, then you have to sync your microservice instances, and for that you can use data streaming, stream processing, for instance. And this is the way we do it. So we distribute the stores through the JVMs by using event streaming, and then we have to merge the objects into all instances into the object graph. So the problem is nobody wants to do that in practice. So it's more convenient to have a solution that works automatically, and this is the reason why we created MicroStream cluster. So it provides the complete architecture and infrastructure for you, also starts the infrastructure, the machines you need, so that don't have to deal with all these cloud stuff. But basically, all Java developers are able to build their own cluster infrastructure. This would work. But as I mentioned, it's much more convenient to create a MicroStream cluster by only some mouse clicks. And this is what we provide with the MicroStream Cloud. Soon, some weeks or so, then we start the beta test program.
Any other questions specific about this one? As I said, clustering, I'll answer those 3 questions I think there were. I'll answer them in a moment before we continue then with the agenda and some practical arrangements for today and tomorrow. But Marcus is a very busy man, so if you have a burning question, now is the time, and otherwise I take over again.
I will come back to the training. So if there are some questions,
okay, so
also later. So
if there is something that I cannot answer immediately, then I'll note it down and then we can ask them to Marcus later on. Okay, thank you, Marcus.
Thank you very much.
Then we will see you pop up again later, I guess. So I'm going to take over the screen share again. So about those questions, there was a question, is there only one Java process allowed to open one storage? Yes. Because of concurrency issues or whatever you might call it, there is only one process that can access a storage to write the changes. More on that later, how we store data. But actually, that's not that different from a database. If you look at databases, there are a few exceptions. There are now more those cloud distributed database, but that's more or less the exception. If you access a database, you can have multiple connections, but internally, all those commands are processed sequentially. So you own only one connection at a time. You can also change the data because you have locks, etc. So in that sense, it is not that different. Then related to that, there was a question, how do you sync data between multiple nodes when data is in memory? Then we have that MicroStream cloud solution there, which is based on a Kafka environment. So the idea is that when there is a change made somewhere, that through that Kafka event stream system, all the nodes are informed and that they integrate the changes in the object graph so that all the nodes that are running your application have all the data, what is needed. So that's the enterprise solution, what we mentioned that is now new, which will go in test and beta in a few weeks. You also can use what's called the COM channel, but it's that's also part of the open source version, which is based on the HTTP sockets, where you basically put an object on one side and you get the object back on the other side. So then you have to do it manually, but that's also an option to sync between nodes. And then there is a question on a single storage when more than one JVM is writing the data. Is there not a chance of data override? Yes, same as with the database. If you don't do anything specific, like checking if you update a value, is that current value still the same as what I was expecting it? So for update off, for instance, in Oracle, it's called, then yeah, just the last one wins and overrides your data. So that's not something which you don't have in today's situations. So, okay, then there was a question about the agenda and what we explicitly cover. So let's then start with the agenda and a few housekeeping rules, let's call them, what we can do. So yeah, we have today and tomorrow. So it's this is more or less what I'm planning to cover. So yeah, it's our two different things. So it's not today. Tomorrow is not a repeat of today. It's our two different things. And after that introduction that we had, we are going to build up our entire knowledge of MicroStream, so that at the end of day 2, that you all know all the basics, so that you can start already creating it in your next project. In the sense that it will not be in a clustered environment, but that you need it in those single node situations. That's the basic, the fundamentals training. There is also an advanced one. More on that tomorrow, what we cover in the advanced. At the end, so if you want to learn more, you can subscribe for the advanced one. You see also at day 2, at the end, there is more or less in the afternoon, or the part of tomorrow afternoon, there is to be defined. So if we have specific questions, because for instance, we cover the data storage just on disk, but not, for instance, how to store it on AWS or Azure storage, or writing it to a database instead of just as a blob, as a binary, not as tables, but more on that later. That can be covered tomorrow afternoon. So if you have today and tomorrow morning some things that you say, I like to get a bit more in detail about a specific thing, then that is possible tomorrow afternoon, and then we can tailor that to the needs that you already see for your use case. We had already the introduction. I switched a bit also that, and we introduced ourselves, or a few people introduced themselves, so that's already covered. So the material, there is a GitHub repository. I will put later on the link when you need it for the first time, a link to that GitHub repository. I'll put that in the chat so that you can also download that there, because the idea is also that you do some exercise, that you play with it, so that you can see how it works. Because I can talk here for 2 days, but then when you start using it, you still might have questions. So the idea is also that you do a few hands-on things, that you play with it, that you based on that might have some questions, of course, and that's perfectly okay. As I mentioned on the bottom of the slide, ask as much as questions as possible, because yeah, that's the idea of the training, that I'll give you as much as info as possible. All the examples that I made are created with Maven and Java 11, although the current version also supports Java 8, so that should not be an issue, I guess, to just define that it should that Java 8 should be used, and yeah, an IDE of your choice. That's of course handy to start playing around with the examples. I try to do as much with pure Java SE. So not using any kind of runtime, but later on for making it easier. And tomorrow, for instance, for that lazy loading, what Marcus already mentioned, it is much easier to do that with a runtime. So I prepared a few things. We can do the Jakarta runtimes like Payara Micro, but I also have something around Spring Boot, Quarkus, or Micronaut. So let's go to that later on which runtime you like. There are breaks, of course. There are short breaks before noon and the afternoon, and we also plan a break at around lunchtime. I put here between 12 and 1 o'clock my time, not as I know not everyone is in the same time zone, and it might be that it is 10 minutes after 12 before we started. It just depends on where we are, which topic we have covered, and we can make a nice stop at a certain moment. Already mentioned, and you see that the recording is already running. I hope it's still running, because I don't see it on the top of my screen anymore, so that you can watch some things later on again. So yes, first, are there already some questions about those, about the agenda, about the some practical arrangements that I covered, or can we start with the first thing? So I assume that everyone is okay with it. An overview of what we will cover today and tomorrow, the basic ones, and that's going from the configuration, the start of the storage manager, loading the objects, the object graph into memory, querying data with Java objects, and then saving the data. So I try to make things hopefully a bit clearer, which part is using MicroStream and which part is using pure Java with those colors. And when you are using the MicroStream API and the MicroStream methods to get a few things done. So the developer, of course, needs to perform the configuration, and that's one of the things that we cover today. The configuration of the storage manager, just as you configure the connection to a database, for instance, and that's the use that MicroStream methods for that, just as the same that you need to start it. When that storage manager starts, then there is some magic happening. Let's call it magic, but we will explain a few things so that it is no longer a magic things. That magic is that it loads your data from that external storage into memory as it loads the object graph, so that from that point on, your data is in memory. The idea is that with MicroStream, your memory is the primary source. Of course, you need to have some external storage because otherwise you lose all the data when your process stops. But that primary source is the memory, and that you can just query objects with pure Java. So that's why I've put there that the Duke. I cannot use that Java cup, that coffee cup, because that is trademarked, but I'm allowed to use that Java Duke to indicate that it is pure Java. So querying data with MicroStream, you don't use any MicroStream APIs for that. It is just pure Java Stream APIs, as we will cover today and tomorrow. Besides querying, you also need to save, create new objects, save the data then to the external storage, delete objects. First of all, for the primary storage, your memory, that's pure Java. You can create a new instance, you do update, etc. So that's pure Java. But then with the MicroStream API and a bit of, again, of that magic, then we store that object representation to an external data storage. So I want to give you an idea what you probably all do in your daily jobs. That is, how do you work with, for instance, Hibernate to retrieve data from a database, and what are the pain points for that? And then we can see how MicroStream solves that. So I start with the big showcase that instead of at the end that when we learned everything around MicroStream and use it, I'm going to show it the spectacular thing, how we can achieve something like 100 times faster reading of data instead of using Hibernate. I'm always making the comparison with Hibernate and a database like that. I mentioned Postgres that I'm using here, but actually there is nothing wrong with Hibernate. I'm not sure if it's on the next slide or not. Yeah, there is something else that I want to tell you. There is nothing wrong with Hibernate itself, because the main issue that you have with accessing data in an external system are due to the fact that you are accessing data in an external system. You have latency. Getting the data from your database over the network into your JVM, that takes some time. And that's not because it is Hibernate, that is JDBC, pure JDBC has the same problem. And as mentioned also in Marcus's presentation, you store data in a database, in a NoSQL solution, in an in-memory data grid as JSON, or in what kind of format you like to store it, and in a column-based storage or whatever. But all those storages are not the native Java object. There is a difference. with the database, they have even a name for that, the impedance mismatch. You can look that up, and there you get more info. But basically, it comes to the fact that your relational, the data model is different than how objects are created in memory and how they are linked together. So that mapping between your external storage and your Java object is the key for that accessing data in a database is slow. And that has nothing to do with Hibernate, because Hibernate is fine. It can do a lot of things. But yeah, it cannot work around those things. It helps you a lot, but can also give you headaches. And as we all know, the data is everywhere. Without data, you probably won't have an application. So data is really important and used daily because that's the nature of why we have enterprise applications.
Rudy, I have a question.
Yep.
Regarding the point of the impedance mismatch.
Yep.
The traditional reason why this mismatch was introduced is because object graphs in memory tend to be volatile over time, right? They tend to change a lot with version updates, Java runtime updates, maybe MicroStreams updates even. Like how are we protected against this with MicroStreams? Is there like a guarantee that the object graph version doesn't change ever or something?
Yeah, there are two things. When you mentioned that there are changes in the representation, do you mean then that your data model changes because you have an additional?
No, changes in my schema are obviously my own problem, right?
Yeah.
Schema changes I have to deal with, but the format, I guess, binary format or object graph changes of MicroStreams, like could they change, for example, if we update to Java 17 or 19, or could they change if we update to MicroStreams, version 50 or whatever comes in the future?
I thought I had a slide behind this one, but maybe it's not there, or it is much further down the presentation. Well, the MicroStream magic, what I mentioned, is actually that we write a binary representation of your objects, which are in memory. In that object graph, we don't write everything out, of course. You have to specify what it is, more on that later, for those who did not play with it. And that binary representation, which is stored on disk or elsewhere, persisted elsewhere, then that will, of course, not change. If you are storing something with, as you mentioned, Java 17, or with Java 11, we have one fixed format which does not change. If you read it back again, then of course, then it is our responsibility, the MicroStream developers, that we can recreate based on that binary representation the objects in memory for the Java version. So if it changes with Java 50, then we need to make sure that that binary representation can be recreated in the JVM for Java version 50. So I hope that's what is that answers your question.
Yes, very good.
Yeah.
Thank you.
And yes, because there was that question already, do we use that the JVM serialization? No, we don't use it. So we use our own one. So that means that we are using really low level APIs of the JVM to even create a Java object in memory without the constructor. So that means that we are safe and secure. We are not using any kind of method when we do the deserialization, and that you don't have those security issues that you have with the JVM native serialization. but that also means that we are really depending on those low-level APIs, and there are already a few changes in the last few years, mainly to that modularization. And so, yeah, that can be sometimes for us tricky to make sure that that binary representation can be used to recreate the object. But yeah, that's our problem. So hopefully when Java 50 is out, which is in in 15 years, we are still able to do what we are doing today. There is another question: does the binary representation depend on the JVM implementation? No, because the JVMs, they all need to follow the JVM specifications. So that means if you're using a certified, and even if they are not certified, most of the time they are based on the OpenJDK1 source code. So that means that we only need to have one way of creating those objects again from the binary representation. If you are running on the on mobile with Kotlin, for instance, on your mobile phone, that's also something that we support. There we need to do sometimes a few things specifically to handle a few specific object types that are only available on the on those runtimes. But in general, no, everything is the same, which is luckily for us that we only have to write it once and then it works on every JVM implementation. So back to that performance demo, but again, no problem of all those questions. So this is the schema that I have created. We have that bookstore demo for those who have looked around at our examples, etc. We have that bookstore application, and this is the schema for that, where you have here in the center, you have a shop where you sell books, and a shop has an address, a city, a state, and a country. And within that shop, you have where is it? You have the inventory. So here at the bottom, you have an inventory of books that are available, and a book has an author and a publisher, which has again another city, state, and country. And a customer here on the right can buy a book in that shop, so that it makes a purchase, and a purchase item is of course a book or multiple books. The data is also available on that GitHub. So I filled, we generate some random data with it with the Java Faker library. We can generate data, a small set data, a large set data, so that you can see the impact of the data set size to the performance about the timings. And then we have that same data set, we can store it in the MicroStream serialization, and we can also store it in a database like Postgres when I did. And then we can perform a query and see how it goes. What is the query that I'm using for this example? And it's a more complex one, but because there you can see, of course, a greater benefit, but also for the small ones, like for instance, like a paged query of the customer table, reading 100 records and then again 100, etc. Even that one is like 5 to 7 times faster. But even with a more complex one, you run into then those specific things of Hibernate, which can sometimes give you a lot of headaches, debugging sessions, and add to that performance issue. What is the query? Well, we look for purchases. So we try to find all purchases of a customer which lives not in the same city as the shop itself. So I called it foreigners. It was originally called purchases by foreigners, but actually it is just in a different city. So if a customer which lives in another city than the shop itself, then we would like to have that list of all of those purchases and with information of which book they bought and the author, of course. And we want to limit that query for a certain country, shops in a certain country for a certain year. So that can be purchases made in 2021, for example. I'm not going into detail with all the code. As I said, it is on the GitHub. I come back tomorrow afternoon to clarify a few things more in detail of what you can find here. But this is the query. This is the query. So I have entities, and I have an entity then for purchase, of course, and I want to select all those purchase entities, as I said, for a certain year. So I'm using here that extract a year from timestamp. This is some function that Hibernate supports, because most databases support that for timestamps for a certain year where the address of the shop is in a certain country. And the other requirement was that the city of the shop is different than the city of the customer. And then I do a lot of joint fetches. Joint fetches because the idea is if you that the entire address information, like address, city, state, and country, is one single data information in your application. In your database, it is stored in 4 different tables, but actually it is one data element, and that's in this, of course, vital to know, to see where which shop it then was and where the customer lived. And so we do that same thing for joining, fetching the address, etc., also for the customer. And as I said, for we like to know which books they bought. So we need to have also the book. So we do a joint fetch of the items and a joint fetch of the books. It's pure Java SE, but again, that does not really matter, but it makes a few things easier. So I have here that test what I do, and I have a few timings. So I have a stopwatch which just keeps the time when we start and when we, for instance, have accessed the database. So when we have opened the Hibernate session based on the configuration we have here, an XML configuration of where the database is with a username, password, and the location. So it is on my local host. It's running within a Docker container. We have all those mappings, etc. So based on this one, we open a session factory and we see how long that takes. And then I have here that method which has that select, as I said. I can create a query, set the parameters, get the result list, and see how long this time took at creating the query, getting the results. That's what is called the cold case. It's the first time in a query do in that Hibernate session. So I need to initialize more things. So I do it again in a hot run, exactly the same thing, but this time in the same session that we have already. In the same session was already there. So we can expect that it goes faster, and indeed it goes faster, but we will see how much faster. Any question? Okay, you don't need to have all the details, but I guess you see what I'm trying to do. Just a not that simple query, because I need to join a lot of things and just getting the data which is more or less, I hope that's more or less standard, but I guess a lot of people work like this. So I see 1 thumbs up, so I guess it's all good and I can run it. I've done this, of course, in a more controlled environment, and here now it's screen sharing and all those things. So that's you will see the numbers in a moment. So the database access itself took 2 seconds and 10 milliseconds. So let's say that it took 2 seconds. What did it do in those 2 seconds? It opened the connection to the database, of course, and it initialized the entire Hibernate system because I have also a custom mapper for that the prices are internally within Java are represented by that money API. So I have a custom converter for that. He needs to initialize that connection pool minimum 1. So he only opens once, but you see he does quite some few things in that 2 seconds. Of course, that's only the first time this second connection goes faster. The cold case takes 864 milliseconds for 1 query. Do you think that's a lot, or do you think that's something that you see common in your applications? No one who wants to a lot. So yeah, that's a lot, but it is also common, says someone. So I guess indeed it is a long time, but it is not unusual. Of course, the second time in a hot run, it only took 96 milliseconds because basically that session had a lot of object already stored in his primary cache. That's also something that you can keep in mind, that Hibernate and then JPA, the specification there is explicitly mentioning of those 2 caches, the first level cache and the second level cache. So that means that if you need a cache, something is slow. So okay, 96 milliseconds the second time, because everything is in that session again. That's better, but okay, that's only because we are using the same session. If a different user is querying even the same data, then you probably will not have that optimal value. We have here, and I'll tell you later what it is, channel. So I have here the same set of data here in a binary format of MicroStream. Binary format, so yeah, that this is useless, but MicroStream can recreate based on all these files, all these binary files. He can create again the objects. One thing that I said, when you start the storage manager, let me show you the code. So we start. Don't be worried about what is that here all about. So at a certain point, I start the storage manager. The rest we will cover in the next hours and days. It loads the data in memory, as I said in the beginning, and what is the idea of MicroStream. But not all data is loaded. For instance, because the also thing that we will cover is historic data. It's purchases. Because it is historic data, we don't load by default all the data of all the purchases that are made during the entire existence of our shop, of our company. So we are doing what's called lazy loading. More on that tomorrow. So that means that those purchases that we are interested in are not loaded at the beginning. They are only loaded when we are actually querying them for, like in this query, we want to have the purchases of a certain year, and the year is year 2021. Doing more or less the same, doing more or less the same timings. So we start before we create this storage manager. So here the main time that which we will report here in this timing is that time needed to load the data from the external system, from the storage. And then we also do a query, but that's then pure based on Java 8 streams. So it's a bit, there are a few things here, but there are here just using the Java streams API to get the data, same data, then with running with Hibernate and the Postgres database. So if we run that, then it takes 2 seconds and 400 milliseconds to load actually the database, except those lazy references. So that's more or less the same as that Hibernate, so that's initial one. And that's purely the one time that we need to do it. The first query, the cold query, took only 96 milliseconds, which is comparable to the hot load of the Hibernate one. So even if he needs to load, and it is around 200,000 records in this case of those purchases made in that certain year, it's about 200,000. It takes, and then finding the data, what we need, is taking only 96 seconds. And look at this one. If the data is loaded, so also the lazy data, so it is comparable to the Hibernate session, I get the data in half a millisecond. Nice, no? Why is then Hibernate slow? Did we do something wrong? Let's see. Or is it really what I said? And we did some testing with a lot of examples. Is it only purely the case of that we are using an external system and also need to do that mapping? So I activate the generate statistics and the show SQLs. So when we run that Hibernate query here, so let's have a look what he is doing. Hibernate, why is it taking 10 times to 100 times more? And then we see that it creates 3 JDBC connections. That's one for the metadata, and then twice because we do a query 2 times, so it creates indeed two connections. That's maybe already a bit of an overhead, but then this is disturbing. For our 2 queries that we do, because we do a cold one and hot one, he executes actually 342 JDBC statements. What? What are those statements? We see that he's reading from the author a lot from the author. Why is that? That's because we have defined here in our book entity that although we say eager, we have a many-to-one from the book to the author entity, we say do it eagerly. Apparently, yeah, our query was already too complex or whatever. He did not include it here. So when we fetch the books, he is not including it there. I get the comment here, Hibernate as lazy loading too. Yeah, but I asked there to perform a eager loading, and still he does a lazy loading. So that's what we also say that yeah, Hibernate is fine, but you need to do sometimes a lot of tuning and finding out. And actually, we need something like this, that we fetch the author here in our query also explicitly. Okay, run it. See if this, yes, this is one. See if it solves the 342 queries. Okay, now 6 JDBC statements. What are the few? Yeah, it still loads a few languages because we have book has also a language. But okay, suppose that we are now happy with the 6 queries. Did we dramatically improve the performance? So putting out the statistics to again to have the same thing. Now it is not 800 but 400 milliseconds, and I don't remember exactly this value anymore, but it is still a bit faster. 136, not that much faster, but still 136 milliseconds instead of half a millisecond. So that's a factor of 270. And actually, it was easier because we did not need to tune our queries, etc. So that's that is a gain that we have over MicroStream. So that's the idea. So Hibernate's fine, JDBC is fine, NoSQL, whatever is fine, but you need to do a lot of tuning, a lot of debugging, and at the end, with MicroStream, you can even go much faster. There was a message from Rizwan. Still, yeah, you're still doing it only to me, but that's fine. Is MicroStream suitable for cloud functions? Example, Amazon Lambdas. Yes, because it's pure Java. So you can use it in serverless. Try to make them, of course, as much as possible with lazy loading, so that you don't load everything over and over again, and only load things that you need for handling your request. The startup is more than 2 seconds. Can we reduce it? You mean in the MicroStream case? Yes, it's only a one-time. You don't need to do it for every connection or whatever. It is just one time at startup. It is 2 seconds. We probably can reduce it by using more lazy loading, so that you not load the data in memory, but more on lazy loading, and pros and cons, and how you should balance that is scheduled for tomorrow. So this is then the performance comparison. The first one, these are the values. You see these are lower because I was not doing screen sharing. I was not doing internet connection, etc., etc. So the first time loading was 1.6 seconds of MicroStream itself. So loading the data, setting up the system. And the actual query was 77 milliseconds, which includes that lazy loading of those 200,000 records. Hibernate, I would say that's comparable because it's not super scientific. So even if it's 100 milliseconds difference, I would say it is the same initializing, but the query takes 10 times more the first time, and even much faster between the MicroStream and Hibernate at the second time if you do the query. So then you see there is 170 times faster, and that's because we are using the same Hibernate session, exactly the same. So that's will not always be the case in your application. And again, basically what you're hitting is the latency numbers. If you just have a memory reference that's 100 nanoseconds, that's just referencing something in memory, and then if you want to compare it, if you read 1 megabyte from memory into your CPU registers, then that is in total 250 microseconds, which is of course much faster than, for instance, reading 1 megabyte sequentially from a solid state drive, which is faster than a normal drive, but okay, it's still four times slower. So if you put your data on a solid state drive, then of course that is beneficial for the loading. But yeah, for instance, here a round trip within the same data center takes already some time. So that's not even taking data from somewhere. So if you send a packet from across the Atlantic, then yeah, you see, then you have 150 milliseconds. So always take care if you're running, and that's a general thing. It's not with it's not only MicroStream. If you're running in the cloud, make sure that your data are located in the same center, the same area than you're processing, because that latency numbers will hit you very hard. So this is how traditionally we are working. We have objects in memory. We have an object graph where we need a mapping and data conversion, because we have an external system which has another format, tables, key value stores, or data grids, for instance, also in JSON. And this is how we hopefully should work after tomorrow, where we have, instead of that big block here for, because there is also a lot of functionality, learning Hibernate with all the options, the possibilities, or any kind of other tool takes, that's quite a big lump of material, a lot of methods, a lot of classes, a lot of things that you need to know. MicroStream is much slimmer, much smaller. You can learn it in 2 days, as you will see. And then you store your objects in a binary format somewhere externally. That can be on a disk. That can also be a cloud storage, Amazon S3 or Azure storage, for example. But it can also be as a blob, as a binary. So it's not that we store it inside tables in fields and columns, but we can store it in a blob in a database, or in any NoSQL solution, or even, as we mentioned, event streaming like Kafka. That was an introduction of what you can expect. So from MicroStream, from performance, that's also short introduction what from Marcus, what the overall picture. And the next things that we then go to do is step by step building up all the info that you need to be able to create something like that performance demo, so that you can create those things yourself. There was a question that I should go back to this slide. Is it correct about the multiple indexes? The next one. Yeah, so there, I just mentioned that indeed, if you have those multiple indexes, that, yeah, you have a small overhead, because again, you have an additional link, additional reference, and that you also need to keep it in sync, and that you need to have a balance between performance and accessibility in the sense of easier access to your data. Not sure if you have any other questions. Okay, no, it's okay. Then we all covered that. Yeah, that's the downside of animations. You have to go through them to go to the next slides. So the configuration, we already saw that at minimum, you need to define, you need to specify for MicroStream that a certain object which is the root, which cannot be NOLL. That's something I did not mention. So you always have to have a real object, but it is filled then, if there are data, it is filled with the actual data that it can be found in the storage. So that is a second minimal piece of information that you need to supply it. Where is the storage located? We go more on examples, but first a bit on terminology and what it is. So the storage manager is your first class, is the main class that you access from the API from MicroStream. And we have seen that you can start it, and for saving data, that's also your starting point. But from that storage manager on, you can access several sub systems, which we will see some of them, and internally, and that's also set up through the configuration. Normally you don't interact with it anymore after the configuration, but you also set the channels. A channel, you have to see it as a thread. Well, in fact, it is an actual thread. A thread which is started when the storage manager is started, which handles the basically the I/O, the input/output, reading from the file, writing to the file in our case, and on the fly performing also the serialization. So within each channel, because you can have multiple ones, within each channel there is then the code called to serialize it based on that the type dictionary that we saw, that the mapping between the unique IDs and the classes and the properties within your classes. So that serializer runs within the channel each time. So it's called each time from within the thread, from within that I/O functionality. For each channel as endpoint, it has that AFS implementation, the abstract file system implementation. As I mentioned in the overview of the dependencies, but when you put in your application, then you have an implementation for the disk or SQL systems or blob storages, and blob storages also include the things like Kafka, Amazon S3, etc. Why multiple channels? When multiple channels, that can help speeding up reading your data. So at the beginning, when your application starts, when your storage manager starts, it reads it scans the entire storage here to see what is there and what needs to be loaded. Except those lazy loaded references, all the other references are loaded, are stored into memory and into your root object. So if you have multiple channels, multiple threads doing that work, then of course that speeds up the loading. And that can make that your application starts a bit faster, or most of the time you only start your storage manager at the first request and not when your application starts. Mainly in cloud environments, that's the case, because if you're running on Kubernetes, for instance, if your application running in Kubernetes, it might be the case that if you store it in a database, that your database is not up and running yet, because otherwise you have dependencies, and you like to avoid that in cloud environments, that something must be up and running before something else can start. It is possible, and you can set dependencies, and sometimes it cannot be avoided, but if it can be avoided, then you don't like to have those things. So that means that the storage manager only starts with the first request. So having more channels there helps in speeding up so that the system is ready. Channels not only is for reading, but also for writing. So that means that if you have at a certain moment a lot of data that needs to be persisted, that can be uploads, that can be maybe a high amount of users that store large data or whatever, then again, it helps speeding up that process, speeding up that storage of that binary data. Come to in a moment on how you configure those channels. The channel count needs to be I come to that question. There is a question about having multiple storage manager in one JVM. Is that possible? Is it recommended? Is it possible? Is it okay or not? I come to that in a moment. First, continue on those channels. That channel count number must be a power of 2. So it can be 1, 2, 4, 8, 16, 32, etc., etc. Why is that? If you provide another value like 12, then that will give an exception at startup, so it will not work. The reason is that for that is how we determine where each object goes. So each object, you can pass a reference to the method, the system.identity hashcode. That's not a very well-known method, but basically that identity hashcode returns a long value as hashcode if you don't have a hashcode defined yourself. It's not a unique value, but it is a value that is assigned once to an object. And even if your content changes, like your string or whatever changes, which is kept within that object, your identity hashcode is still the same. And that's an initial value when your object is instantiated. Based on that identity hashcode, we take the last X number of bits. So if you define the channel count as 4, we are taking the last 2 bits. And we see what value is there in the last 2 bits. Is that 0, 1, 2, or 3? You can have either of the 2 bits can be high. So you have the values of 0, 1, 2, and 3. So that makes 4 different values. So based on that last 2 bits of the identity hashcode, we can determine where a object goes. Is that to the first channel, the second, the third, or the fourth channel, based on that value. So that is the reason why the channel count needs to be the power of 2. As I said, when should you change the default values? When is 1, when should you change it to 2 or 4 or maybe higher number? That depends if you have a large initial data set to load, or you have many you have a high object change rate, as I call it. That if you change objects a lot and there are a lot of changes and you need to store them every time, then it can also help to put a higher count. Of course, having 4 channels instead of 1 does not make your program entirely 4 times faster. And you know that's it is faster, but not necessarily 4 times. So and ideally, your channel count, your number of threads should not exceed the number of physical CPU cores which are available to your processor. Because if you are on a to have an extreme example, if you're running on a single core machine, then it does not benefit to define 16 channel counts, because those 16 threads share a single CPU, which means that it will be slower defining 16 threads than only one thread as one channel. So look at the configuration of your machines where you're going to run and make a good, well-defined the decision about that value. That is important because you cannot change that value easily. So if you have started if you have already a database with, for instance, channel count 2, and you try to start it up with 4, then it will fail, because it sees that the number of channels which are already there, so the number of files which are already there, does not match the channel count, and that does not work. Same for if you go from 4 to 2. So there is a tool now available to change your storage, change your storage from disk to database, so from one system to another, or change the channel count, which means reading the entire data set and writing it out again with a new configuration. So there you can change the number for the channel counts, but not on the fly by just stopping your application and starting it up again. So it's something that you need to think about. Back to the code, where I then cover the question. Let's this first. Can we have multiple storage managers? Yes, you can have 2, 5, 10, 20, whatever storage managers you like, but be aware that they should be connected to different paths, different directories. So they should not, as it was mentioned, you should not have 2 storage managers that point to the same directory here, because then 2 different processes, 2 different threads, to whatever, will read and write from that same location, which means that you will have conflicts and that eventually you end up with a corrupted database. But it is just as you have possibility to use different databases in your application, because of you think that you have 2 really distinct set of data, and you will want to keep them in a separate directory, then it's perfectly fine to have 2 different storage managers. And they can have different configuration. One can have 1 channel, the other can have 4 channels or whatever. That's possible. So this is the minimum. This is just start me with the minimum 2 required. But most of the time you want to have a little bit more control over the entire configuration. You need the possibility to define a bit more of the things. And then we have the possibility to use a builder. A builder to define the different aspects of your configuration. When you are using the builder, you need that that second dependency here. What I mentioned in the beginning, you have the base one with the embedded. This configuration one is does contain this configuration because this class embedded storage configuration is in that second dependency. And that builder, you can then specify there that directory. That's again what we had before, and you can set for here, for example, the channel count. You have other possibilities to specify through that builder, which you don't have with that simple one. We have the possibilities to define backups and backup directories, but backups is handled more in detail tomorrow. So I come back to that tomorrow. But you also have other things that you can say the channel directory prefix. That's here that channel underscore. So if you don't like that name channel underscore for whatever reason, as of the 0, 1, and that's just a number that indicates the number of the channel. But if you don't like that underscore, then you can define another one. It was not the case here because there was not much data saved, but when we store things in the storage, which we will cover in the next section, in Lars' section after this one, how we can store things. But I can say now already that we store changes. We append changes to the system, to what you have changed in the memory to this file. So that means that this file grows. It also gets cleaned up and etc. That's another thing, which I will cover later. But you want to set a maximum size for that that file, because yeah, very large files sometimes are not handled very well by operating system or disk systems or whatever. So you can set the maximum file size. I don't know the default value by heart, what it is, but there is also a default file. This is what the minimum size and the minimum use ratio is, also the household keeping process, which I cover tomorrow, how we clean up these storages, because as I said, when we only append things to a file, well, that would mean that your disk would be full at some point. So only by updating one single object, you would have a million different versions of that object. So that's not happening. There is a cleanup. So this minimum size is there. And I will cover that tomorrow. Again, we have that data file prefix and data file suffix. That's here, that channel again. So it's not because the directory is called channel underscore 0, that also needs to be the case here of the file, and that dot the dat file, that's here, that suffix. So you see also the housekeeping interval for Windows systems only. You have a log file, etc. So you can define a lot of the configuration, small things, which we are not going to cover in detail here. You just need to know that they exist. But you can define all those values here with that builder. There is a question, correct me if I'm wrong. Once you have set up the channel count and you're storing, you cannot, if you change, you cannot retrieve your data. Yes, correct. Your channel here, your channel count, you can only set it on an empty database for the first time, because otherwise there is a mismatch between your config and it does not find all the objects in the channels, etc. So maybe because you joined, I think joined just a bit later than I mentioned it, that there is a tool that can convert your data set from one system to another, from, for instance, here disk to database, and there or from disk to disk, where you just change then the count. So that's possible. I will share the GitHub link in a moment for this project again. But I can do exactly the same. So it's basically the only thing that I did differently here with this configuration is that instead of just defining a directory and the root, I can also set the root here. I also set the channel count in this case. So if you do it programmatically, because there are other ways, if you do it programmatically, most of the time people use this one. But you see also there are 3 steps. You set basic configuration things, and then you create a foundation out of it. A foundation is actually a class. You see that it's embedded storage foundation, which contains all the configuration which you still can customize. I will show you an example in a moment. Because there is so many things to configure. Remember, I said configuration is the hardest thing. Well, there are probably something like 70 to 100 different aspects that you can configure. There are so many things that even with a builder, that's sometimes not possible. So yeah, we create then something underlying underneath a foundation. Here we only set that root object, but you can set other things. Once you have that foundation, then you can create that storage manager out of all the info that it needs, default or otherwise, and you have to start it. So with that simple case, we just called the start. We said here just start, but actually underlying, it creates then a foundation. It creates the storage manager and it starts the storage manager all behind this method. So where is it? The builder here again. So that single method is more or less the same that we did here, except that we are specifying here an additional channel count. As I mentioned, if you do it programmatically, this is most of the time the way to go. What people use. Hello world things and things to play. You can of course use that very simple one. Again, the same thing, these 13 books. And you have here a config now with four channels. Here are already 2 files created in the channel. So based on that config, you have that builder one. Okay, thank you, Marianne, for putting that GitHub link already. But it's not, yeah, no. First I'm going to do the foundation, because I mentioned the foundation. You can start from the foundation yourself, but that's a bit of work. You will see why. This is how you do the same thing that we did before. Well, I specify also a backup one. But this is how you create that foundation. So as I said, there are a lot of things. So there are different methods. Here you need to also specify implementations of those interfaces. As I mentioned, everything is an interface within MicroStream. So that means that it is quite a bit of work to do it on the foundation itself. So this is not very common, but you can start with a new foundation. Yeah, that's then kind of builder here again, because that's not a new keyword, but that's just a static method which provides a builder for this foundation, where you can set the configuration, where you can set the root, and the configuration is then again a builder. But yeah, you see we are not always super consistent in naming, where you provide a storage file provider. That means a provider that connects to the correct way of storing, which is then in this case the non-blocking IO file system, which we specify here with the directory. We need to specify a provider for the channel count, we need to define the backup in case we do it. We can create a configuration, we can set a root, and then based on that foundation, we create a storage manager and we start it. So this is only needed, it is placed here because if you have ever the need to change one of those interfaces, which are used underlying in MicroStream, the default implementations of those interfaces, because you want to do something special. I don't know, there is always, someone always wants to do something different, and they have most of the time good reasons for it. So that's why we giving that opportunity, but you see that's of course the very long way. So if you're not in that case, then this is not the preferred way of defining your configuration programmatically. That builder is much simpler, and you have the same functionality. I've put it here, but I could have also, and maybe I'm going to do it then, because then it's more clear. This is working just on that foundation. So that means that if you have that builder here, I cannot do it because then I don't have that that one single statement anymore. But so suppose that I have created a variable, and then namely foundation out of it in 2 steps. Then I can do the same things here in that builder step, but then of course I don't have one single statement anymore, but I need to split it up in a few other things. That is more, that is quite common to, based on that foundation, that you add a few additional things. And there are 2 main things. There are, again, several options possible. The point here is that in application runtimes like Spring Boot, especially when you are using the developer mode, the dev mode, but also in other systems where you have multiple level, you have class loaders in multiple levels, then it is possible that your storage manager is loaded by another class loader than the root. You have your root class with or book and user, for example. That can be in another class loader which is not accessible from your system class loader from your application runtime, which means that you get an error class not found when it's trying to load the data from the storage. This command is then your key. This is then what you need to do. That is that you specify the class loader which will be used by MicroStream to load the classes like your user, your book, and your etc., your other classes. Most of the time it is enough, but it can again depend on the runtime. Most of the time it is enough to specify the context class loader of the current thread here, and then MicroStream will use that one. What are specialized handlers? Again, that's something more advanced, but in short, there is always there is a generic handler that handles the conversion from a Java object to the binary representation and vice versa, based on this type dictionary. As I mentioned, this is the key to say that code. That's in this case, it is a primitive 8-bit integer set. There is a handler, a generic handler that can handle all classes that can exist in the JVM, which is good, but some classes, if we could have not a generic one, but a specialized one that say, oh, if it, for instance, is and we have that one, if it's an immutable list, you have that immutable version of an array list, then that generic handler can do its job, no problem, but it's not the most efficient way. And these specific handlers are, for instance, available. And you can register them, and then whenever the system encounters that object type, then it uses that specialized handler to do the processing on your object or on that specific data block in your data storage, which means it goes a bit faster. For instance, that there was in JDK 17, there was a new type of list and set introduced. You can register those using that storage foundation. It's encoded here because they are in different Maven dependencies, because they are only usable on JDK 17 and higher. So that means that without it on JDK 11 here, I cannot get this to compile and run because it would not work, because it requires JDK 17. So the class loader and the specialized handlers, you can create again your own handlers, but I would not recommend that, because it's you probably need to know a few things internally, how MicroStream works, etc. So it's a bit of expertise required, but it is possible to use predefined ones which we have defined. The same is done automatically, for instance, on Android, on mobile devices. There we also have a set of specific handlers for classes that you only encounter on those environments. So these are the three ways of defining your config. Oh, I can run it again, but that's again, we'll do exactly the same. So it creates a directory foundation config, and it has 8 channels. So here is my foundation config with 8 channels. And since I have defined the backup, but more on that tomorrow, I have the same thing here also as a backup. Any question on setting the configuration in this way? Next thing is define it in an external file, but by using the programmatic way, is there any question for the moment? All good, fine. Very clear, thank you. Programmatic way, as I said, fine, but yeah, most of the time you need to specify, or you should specify, configuration files externally to your app and not inside your app, because then if you would like to change it, you need to recompile it, and yeah, you know all the things about deploying the same app in test and production, etc. So it most of the time people want to do it outside. So there are 2 ways by default here defined how you can do it externally. So you can have a resource in the resource that can be within, again, it is here within my project itself, but it can be it can be placed anywhere on the disk, etc. Where you define key value pairs. Key value pairs, in this case, it says the directory where it is stored is this one, and the number of channels that you need to use is this one. You can do it as a property files. You can do it by default as an XML file. What are the possible values? Then that's the reason why I've put it here. There is here a in the documentation, we have docs.microstream.when, where we have the entire configuration explained, but also other concepts. But in the configuration, we have those properties here where we have defined the properties that you can specify. These are only for, you see, there are others for the channel, there are, and for instance, for the database, etc., there are other properties that are specified in storage targets, I guess, here indeed SQL database, for instance, for progress. You have here those properties specific for progress, which we come to them tomorrow, I guess. Yes, there is a question. As my answer is yes, but I will say it in a moment. So these properties, as you saw me using storage directory, is that base directory. If you don't specify it, and that's also the case if you do it programmatically, if you don't specify it, the default value is storage, but I guess you will always specify it. There is also a storage-file system that's actually a prefix that then indicates, will it be SQL, will it be a blob storage like Amazon S3, etc., etc. Deletion directory, instead of deleting files, we just move files. Same for that backup, blah, 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 channel count, as we saw it, that prefix files, a suffix, etc., etc. Have a look at all those properties, not going to go over them, each of them. But whatever you can do programmatically, you can do, of course, here with these configuration for properties. So for every, especially in that builder, what I saw for each property here there is most cases, except for that storage file system, that's a special one, but for the rest, there are always a corresponding method for it. How do we load it? And then we come to that other question, do we need to worry about the class loader? How do we load it? Well, we again use that embedded storage configuration, but now not builder as it was before, but load. And then we specify a file here. And we specify these storage.properties, or we can specify storage.xml. The extension is important, meaning if it's .properties, then it expects that it is a file which is has the format of properties. So key equals value. If it's XML as suffix X, it expects a XML file with root properties, and each property defined as this one. So a tag property with attributes name and value. So based on the extension, this load method knows what type the file is and knows how to load it. Again, this is an interface. If you have another type, for instance, YAML, then you can provide your own YAML reader, and you can provide the key value pairs to that configuration object using your own code. Once all this is loaded, then we are able to create that storage foundation again. We can set a root, storage manager, and start it. And there was a question, do we worry about class loader? Yes, that's the same, that's not handled for you automatically. So that means if you need to set the class loader, then you foundation, you have to here again that foundation on connection foundation, and then you have here to set that class loader. I don't know it by heart, but it is something like set class loader provider. Yes. So you can do it the same again here. that's an option. For the integrations, we have integrations for Jakarta, EE, and MicroProfile. For those runtimes, we have an integration for Spring Boot. There are provided by the vendors itself integrations for Micronaut and Helidon. They have also integrations to have this kind of property files, for instance, for Spring Boot, for example, that it is loaded through the Spring config system. So there you're not limited to here, for instance, that property files that you need to point. Then you can use the entire Spring functionality to provide you those configuration files. So that's one of the integrations, the benefits of the integrations that we have. For instance, for the Quarkus, because for Quarkus you always need that class loader, that specific class loader, then that is applied automatically, because if you need to specify before it works, then then it's better that we provide it for you, because otherwise people will always run against the same problem, and that's of course not a good situation. Yeah, I can run this again. It's not that much different from before. We have those 13 books, and this time we have it in the external config. So in this one, two channels. And of course, it does not depend the storage on where the properties come from. So, because if I'm correctly, then both the XML and the property ones have the same value, external config and 2. So if I just change that way of reading the config, then everything is still fine, and he gets my again my 13 books which are coming from data are already available, nothing to do. So he's reading it from this file, of course, because it does not matter where he reads the properties from, of course. That's basic configuration stuff. We have also, unless there are, as you saw it on the agenda, unless there are a lot of other questions, we also cover tomorrow, for instance, cloud storages, we cover database, etc. But they all work more or less in the same way. Especially if you know, if you look at this one is the most comprehensive in that way, that you have specify values, create a foundation, customize that foundation for any kind of special requirements, set the routes, create the storage manager, and start it. One thing, what you need to be aware of, which I ran into when I started working with MicroStream. When you have a storage manager, that's fine, but you can stop it. That's also possible. But once it is stopped, you cannot start it again. You cannot start it anymore. So a stopped storage manager cannot be reused. And also a foundation which is used for creating that storage manager cannot be reused. That is a problem from our side that we need to address, because foundation is in theory only config, but apparently at some point there was an error and a mistake made that this create embedded storage manager modifies the underlying foundation, which means it cannot be reused anymore, because then the second time it is not, it does not have the expected state anymore, and then you get an exception. So that the storage manager can only be used, can only be started once and stopped once, that is by design, that is by intention. fact that you cannot reuse a foundation will be solved at some point, but today you cannot reuse a foundation either. And I guess that's about it, but I have to tell about config for the moment. As I said, tomorrow a bit more. Any questions for the moment? I'll cover that question about testing immediately. And I will show something about the integration in Spring Boot, because that was also a question. But other than that, are there other things that you like to know for the moment? Clarifying my test-related question, is there a configuration which basically creates fake storage which fulfills storage API contract if you can store stuff but does not do any magic serialization? Yes, you just use plain Java objects. That was the answer what I would say you. If you don't need to check if you are actually storing your changes, then yeah, you don't need anything MicroStream specific, so you can just use pure Java. Same for lazy. Lazy is just a Java object. So maybe I can show it you tomorrow when we cover lazy. You can, if it's only reading data, you can provide some test data, whatever you like, during your test, and that works fine. If you need to check writing to see, I perform a request on an endpoint of my application, and it needs to store something. And to actually check that if I have stored everything, yes or no, then of course you need MicroStream and you need something more specific. This is something that I'm playing with. So don't look too much at the details, but try to get the general concept. What I'm doing here is, okay, I have an application, and for testing, I'm using test containers. So I'm starting up my runtime with my application in a test container. And I'm adding a volume mapping. So this is the directory which is configured to store as directory to store my data from MicroStream, and I map that to the target here within my application. That it's now empty because there is nothing, of course. And the idea is that when I start up my application, and yeah, here it was just to check if there are default values applied, I get them back from my endpoint. That's fine. But I also want to know if they are actually stored. So what I'm doing, I'm creating a storage manager. Yes, that was my initial version, which I said it's too long version, which is mapped to this storage directory, target storage data, which is also used internally by that application. So when MicroStream starts up and does everything what it needs, then it does what it needs to do. I put here a sleep to give time to synchronize everything, because those volume mappings are not synchronized instantly. And then I'm accessing my MicroStream storage from my test again to see if that actually my number of users is 2, which is also set here, which I don't return in my endpoint. So that is a way to try it out. be aware that you are, strictly speaking, you are violating something from MicroStream, because that directory is also in use by the application within the Docker container, and I also access at the same time here. So I'm accessing the same storage by two different processes. As long as my process within the container is not writing to it, then I get away with it because it is small and there is no overlap, and I just do a read here by just creating the storage manager, which means it reads the content. But it is tricky and it is not guaranteed that it will work. But this was one of the playgrounds that I'm doing to find a way of working which can actually work so that you can do those things in testing and see what is needed, which changes are required within the framework, so that these kind of things can be possible. But let's say that in 99% of the cases, this will work. Sometimes, especially because you need to synchronize and wait, etc. Then what might fail, what can fail, will fail at some point, of course. This is not a test which is very stable in the sense that it will work 100% guaranteed. That around testing, if you don't need anything to test which is written, then pure Java will work. Second, what I want to show is integrations. Integrations a bit. It's not real next. It's not actually the next point, but I talk a bit about using Spring Boot, Quarkus, or Payara Micro for the example, what we will do this afternoon. But this is an example of the integration. So this is the integration. So this is the MicroStream Spring Boot integration, which then where you can define, for instance, that storage directory, that channel count with which need to be prefixed now in that, for instance, application properties, so that Spring finds it. And what can you do then? Then you can have a Spring Bean component, but we have the same functionality for Jakarta and MicroProfile, for Quarkus, etc. So they are all the same. You can customize that foundation, for instance, by setting and registering those specific JDK 8 or 17 handlers. You can also, if needed, if not done automatically already, set that class loader. So that's done by a certain bean, Spring Bean, CDI bean, whatever, which implements a class. You can also customize the root. So, for instance, you want to specify that if there are no books yet, that you have default data. So that's some initialization. That's also in a separate one. And the other thing here is that you can, for instance, inject, or you should inject your root into, for instance, a other bean. So your root becomes a Spring Bean in this case, because we have that storage here, and that MicroStream integration then scans it, sees that this is your root, and will link it correctly to the storage manager. You can also inject should be able to inject where, how can you inject it? You can also inject this storage manager itself. I don't have an example here. Yeah, here. So you can inject the storage manager. Question is, where are you defining the storage path? Well, that's here. So you see storage directory is here in the target/storage. So again, it is in external, just as a bit external, this property files. And now you have to prepend this one so that we are sure that we are never colliding with any other system that also use Spring config and might maybe have a same storage directory, and then you have, of course, a collision of key names. So that's, I showed Spring because that was a question earlier today, but as I said, we have it for all major systems, major frameworks, and they work all in the same way. So they have all the same, here the same name of that interface. And the only thing what is different is that it is here it is a component. For CDI, it is you need to do it with application scope, but for the rest it is identical. Other questions? If not, continue on one other thing, because this afternoon we are going to make an exercise. After I've explained how you store data, because that's the last missing piece. We have done the configure, we have designed our data model, we know the configuration, and we know how to read, because that's pure Java. Tomorrow a bit more on some tips and tricks with Stream API, but basically that's pure Java. Last thing is storing data. That comes in a moment, and then we have that exercise. An exercise which are using JSON endpoints. So I'm not sure what was the preference of people. So I made a template. I made a template for Micronaut, Payara Micro, Quarkus, and Spring Boot, which you can use for that exercise. I hope you can find the framework that you're familiar with most in one of those four. My intention was also to add more than just Payara Micro as Jakarta, but I did not have the time. Be aware that it does not use the integration. It is just focusing on getting your application and your exercise done. So I will show you in a moment how each template is built, is created, and that's not by using the integration, because the idea is not to focus on a specific framework, but just to focus on how do you do some CRUD operation, create, read, update, and delete with MicroStream. These, if you want to start over again, these templates are generated from their respective starter projects on the web. So for you have Micronaut Launch, where I selected the version Java, Maven, Java 11, including JAX-RS. And with that template, because I've added MicroStream, of course, to the template, although Micronaut has included it, but you need to know how to activate it. I've added, and then you can just use this one. I'm going to use it for Payara Micro. Payara Micro use the micro profile starter project. The same for Spring Boot. You have that initializer where you specify the Spring Web Services as dependency, and for Quarkus you specify REST Easy Classic and the Jackson one, and then you can use it with the dev model of Quarkus. I'm most familiar with Payara Micro, so that's what I will using, but I know enough of the other three to help you if there is a question. Then you can also ask me, and then I'll try to help you. We have the opportunity to create breakout rooms, so if you're really stuck, then through that breakout room, I can try to get you up and running again. If that would be necessary. This is the template for Payara Micro. What I added here is that I added the MicroStream dependency, that embedded configuration. And as I said, it's not using the integration. So I have created here a singleton called DB from database. And you can just, and so it is a singleton. So you can ask for a instance of the storage manager, or you can ask for the root object. And behind the scene, it creates then the storage manager using that builder pattern, and it initialize, namely it initialize with one product. And then you have here a endpoint which, besides the hello world, list all the products. Again, this is purely for focusing on our next task, what we are going to do, and not necessarily the best way of using it within Payara Micro, Spring Boot, Quarkus, or Micronaut. So it's always more or less the same. If you have dev mode, you can just do as like Quarkus and Spring Boot also, you can just do, you can start the dev mode from Maven. I've put it here also in the README, I guess. Yes, it's here in README. You can then start up that jar file that is created. So it is creating a single jar file containing Payara Micro in this case, and your application or whatever is needed. Severe failed to start because it is already started, I guess. I have it somewhere running. Yep, so I have here my hello products. So if I do, let's just curl local host 8080 data hello products, then I get my banana as fruit, which I added there in the initialization data. So yeah, the idea is that you just, through that singleton, you access the root, or you access the storage manager, just for the examples here, to get easy up and running without that integration, because that's, again, is another layer of complexity. Not that much, but I try to keep everything as simple as possible. So how are we going to store data? Yeah, that's what I mentioned, the class loader and the handlers. The templates, you can find them there also on GitHub. So if you download that GitHub project, you have them all. So yeah, we need to store the data externally, because yeah, if your process dies, then you would have lost your data if it's not stored externally. But you need to keep in mind that what we store in that storage on disk or wherever we are going to store it, that's not the primary source. With the database, that is your primary source. There, your database is the primary source, is externally, and you get all the data from there. The idea is that with MicroStream, all your data are in memory, and you use it there in memory. That can be a lazy reference, so that means that it needs to load it from that storage because it's not loaded yet, but it's not the primary source. You always need to keep in mind that MicroStream means that your JVM objects are the database. So if you change your object in memory, you actually have changed your data. If you forget to store it externally, then of course, then you have lost it for the next time. But yeah, that is the idea. Some of the concepts are also based on that idea. For instance, I get a lot of the time a question: how do you do a rollback? Well, that's not a question that you can ask with MicroStream, because rollback means that you're going to a previous state, but you don't have a previous state because you only have that that data in the memory, and if you have overwritten it, well, then it's gone. There are, which you can see in the advanced course, there are ways of, if you have not stored it, of course, that getting the values from the storage back instead of keeping the values that are in memory. But a rollback in that sense does not make much sense. That can also be sometimes difficult. Also, for instance, we get questions about how do we do concurrency? How do what if two people access the same object? Well, again, then you need to use the standard Java ways to handle concurrency. So if you always think about the memory is the primary source, and then you can act accordingly, you're safe. But as I said, when the storage manager is created, everything is loaded from that storage location. But how can you write data back to that storage system for the next time? Because read just the Java API, Stream API, any Java statement. So that's not much that I need to tell tomorrow. A bit more on Streams API, some more advanced things maybe for some people, so that you can use it. Storing data, actually, there is only one method, which is the second one here: store me a certain object. There is also store root, which then just starts from the root object, which you have defined, which you hardly use. But most, let's say 99.9% of the cases, you store a certain object. And when you call this store method, then, for instance, let's say that we start from this object 2, that might be the root or not, that is not really important. So if we start from there, then MicroStream is going to compare the value, all the references, for instance, the string reference to the first name, or the integer value of the price, or the age, or whatever, is going to compare it with the previous version, because it indeed keeps the pointers to the previous version, not the actual values, but only the pointers. So for a string, of course, that does not make any difference, because strings are immutable. If you change the string value, then you have changed the pointer. So, but for other references, that can be important, but we only keep track of the pointers. Otherwise, we would have duplicated every data in your object graph, of course, which can then end up taking up a lot of space. So if that comparison says that the pointer is the same, for instance, at the green one, there is it points to the same object 5 it was before, then okay, then it's not going to store that new pointer value. If it is changed, so for instance, this object 7 is different, well, then it's going to store only to the storage that for this property, I don't know, let's call it first name, that the first name is now a different pointer, and it stores that the pointer and the value, of course, in this case, for first name of object 2. So in that storage, we have most of the time not the entire object's data altogether. We only have differences, and he needs to find out what the actual value is when it starts up. more or less the same as Git. As you know how Git works, Git also stores changes to files from the previous one. Works more or less the same. But more important, this store method, as if we say store to, well, it sees that this green pointer did not change. Well, it stops. It does not check anymore if there are any changes within 5. So actually, we made a change here down the line that we pointed, that needs to be an orange one. We pointed 9, the pointer to 4 was changed. Well, it does not see it. By default, we have what's called the lazy storer, and it stops whenever it encounters a reference that is not changed. In the case of 7, it continues because it sees that the reference to 6 is now another one, and from within 6, the reference to 11 is another one. So if you say that it needs to store object 2 here, then it stores actually 1, 2, 3 pointers and 3 values. The values of 7, 6, and 11, and the pointers from 2 to 7, from 7 to 6, and from 6 to 11. Very important to remember. It traverses your tree graph, but it stops whenever it encounters an unchanged pointer. In that branch, of course. It continues in the other branches, but it stops there when it encounters something that is unchanged. That's the default lazy storer. Default because, yeah, that's most of the time enough. If you just change what is save what is changed, and yeah, the system can find out the whole tree again by looking all the bits and pieces that it finds in that storage, and can create when it starts up the storage manager, it can create the entire object tree again. So that's good enough. Of course, it takes a little bit more time to assemble all those bits and pieces, but it saves space on disk because otherwise, if you have here the root object and you say, save me the root object, and you would change everything, and that would be 100 megabytes of data, then it stores 100 megabytes in your storage again. And maybe there are only a few strings changed, which is, of course, a massive waste of space. However, you can say that instead of the lazy storer, the default one, you use the eager storer, which does not stop at all. So if you say, store me this 100 megabyte from this root object, then it will store it, period. It does not check if there are any changed or unchanged pointers. That's an important principle that I need to tell first before I go to the examples. Is that clear enough for the moment, or is there some things which are still in doubt for some people? You can always ask later, of course. When we are doing the examples that you see, this is not clear for me enough. So that's, of course, possible. So we have here a CRUD. This is because I did not commit all the changes. Oh yeah. We have here two JSON files. One JSON file with book names and information, and at the end there is an author ID which refers to this second JSON file which contains all that information. And I have a few endpoints which need those things to work. I'm not going to spend up time explaining how I read that JSON, etc. It's this method, this class here. So I'm able to create a list of those books, books which then has a reference to an author based on that JSON by using this mockup utils load mockup data. To be 100% sure, I put a comment like here because I'm doing it datetime formatter here, which is actually not thread safe. So don't do this in production code, but it is fine here because I'm only using it from one thread. I put it there because it is not 100% good code. So, and I'm going to start with a few typing a few statements myself, but after a few things, I will go ask for you guys, what is the solution? Because I want to see if you get all the concepts or that there are still some things missing. So this is my root, which is empty. I have a root object, the data root I created, I link it to a storage manager, but it's not initialized with any data. So that means that, where is my data root? My data root, I have here a list of books, but that list of books will always be empty. But to be 100% sure, because we can call this create method over and over again, I clear, not like this, I do get books, I clear my entire list in case it is not empty. And then I'm going to make a reference to this because I'm going to need it multiple times. I'm adding all books that are loaded through this util, so I can just use this one. So now my changes are made already within memory, within my database. But I like to save them, of course. So that's get instance, I get my storage manager, and I store what? I store all the books. I store this pointer. Because, and maybe I should have showed you this slide. I found it and found it funny. Because the rule is with MicroStream, store what is changed. So the object that changed, you have to store it. Not your root, not something else, not some random thing. What is changed, you need to store. That means altered, modified, transformed, different, whatever. So what is changed here? Well, the items within this list, because I did a clear and I did add of items. So the top level, the top root, or how do you call it, object which is changed, which is then traversed by the system, is this list. If there was something, then pointers are different, etc. And he encounters new pointers because this was not in the system before, so they are unique new pointers, and that means that he's going to save everything. So this is actually the way to store all the books that I have loaded together with the authors. And to test it, I have already a get method which just returns the list of those books. So let's try it out. And in the meantime, we can answer any questions if you might have them. doing all those things when you are doing screen sharing presentation is not very fast. So Java -jar target of microbit. And my endpoint is data. I'll need to put it in the comments how you can access data, and then the book controller is just books. Great. So first of all, I'm going to curl localhost 8080 data books, which means nothing, empty, because there was not the, that was done from a previous run, that was not the ID. There was already here a MicroStream data with all the data loaded from testing yesterday. Again, started my application with an empty database. Not this one, the curl one. I have an empty set because, as I said, it was empty, nothing is there. I can do that create, which loads the JSON. If when there is something wrong, it gives me an exception, but most important, I change the memory and then I save the data. Successful. Is it successful? But I'm going to use a browser this time because then I have a nicer representation. You see, I have all those books available with the author there. And it was using 1,000 books, I guess. 1,000 books, yes, 1,000 books. So you see, that was fast. Huh? You can try it with the database. It will not be that fast as what I was doing now here by just using this store. Okay, everyone is still with me? Is it stored or is it just here? Because it is in memory. This is coming from a singleton, so yeah, it might be only in memory, not really stored. So I stop the database. I stop the program. I run it again. And I will do it here now. Then you are sure that it is not cached in my browser. Here, these books. And there are my books again. So this clearly was successful. We stored and we used the rule store what is changed. Oops, I'm in the wrong one because you can also already see the results. Now this is pure Java. So how can I return all the books that start where the name starts with the letter A? And please someone unmute himself and give me the solution.
You can use streams to filter out, start with A's.
Stream. Next is
Filter.
Yeah, you have a filter. Okay.
Book. Yes.
Book. Get name starts with
Yep.
name. And then
collect and return it.
Yeah, you see my IntelliJ is already so clever that he knows what I want to do. It gives me as a first thing. So this is a query that I've written in MicroStream. Well, pure Java, because as we mentioned, MicroStream does not have a query language. I will show it you the results because I'm not going to restart every time. Create another book. Someone else? What code do I need to write here? I have here an author, a new author, and a new book. I need to do two things, the memory thing and the MicroStream thing. Who is going to okay, there is first a question with this one. If the size is big, find remove performance is linear to the number of n, which is slow. Yes, it can be slow. But one of the things that you can do if you have a really large one, then you can build a Lucene index. You all know Lucene, Apache Lucene for searching in documents. You can build a Lucene index on your book object, for instance, and then you can ask Lucene to do that query for you. But I tried it with in that performance demo. We saw it, played a lot with that one. You need a lot of books before Lucene becomes more performant than Java. Don't underestimate Java with his quite good performance, especially Java 17, etc. But you're right, if this are millions of books, then it might not be the most fast, the fastest way. Again, I also said don't put things in one gigantic list of millions and millions. Then you should have already an indexing, maybe on that first letter. But yes,
so
good remark. Yes.
If our data size is quite big, like in billions of records, then we somehow stored it, right?
Yes. Then again, as I said, you need to have a map with lazy loading. Don't put a billion books in a list like this.
But if we want to search it, then should we create some kind of separate indexes? Because then loading those billions of entries to search only one will not make any sense. How it will gonna work?
Yep. Yep. For that, yeah, indeed. Don't put it in one big list because then it's loaded all at once in the when you start your storage manager. So you need to split up the list so that's lazy loaded. If you need to search, then build an Lucene index, which can also be loaded separately, so that first you access the Lucene index to find those entries that you need, and then go to those specific entries by only loading then those entries that you found that you require. Yes. If we talk about billions, etc., then yes, then we have our own challenges, just as any database, I guess. Even in databases, there is already an optimization for that. But if you're not having any kind of index on a row with some millions of records where you just find a record where a field starts with an A, you're also going to do a full table scan, which can also take several seconds, if not 10 seconds to have your results. So that's not different from a database.
In this case, we have to implement this logic as a developer by ourselves. So create indexes or store them somehow and then map those back to the storage.
Yep. That's then the way to go, yes. There was also the question, and when we store a very large modified list, performance is slow. Again, that depends. If it needs to traverse the entire list to find out which items is changed and which not, yes, that of course that takes some time. That's what I said in the beginning already from designing your data model before lunch. Don't use a gigantic list. Split it up. Already based on some kind of indexing mechanism that you find suitable for your queries based on what you do. Okay, there is Thomas is giving me the solution of this one at the books list at the book to the book list, I guess it is. So I'm going to again db get roots get books, add it to the list. And save the books store. You mean that I need to, what do I need to store now? Do I use this one? I see that you're typing, but I cannot see. Do I need to store book or books? Books, multiple. Yes. What is changed? Again, we have added an item to this list. So the list is the one who is changed, so we need to store it. And then again, yes, you're going to go over to those 1,000 books, see if it is changed or not, and store that book.
So can we make this particular step efficient, saying that stored only single book into this list, like append something, or we have always need to store the complete list?
Yeah, we have to say to MicroStream, store the list. He will find out that there is only one item added, and he will only store to the storage. He will only store this one book, but he needs to find out by himself that yeah, actually there were 1,000 unaltered references. There was only one added one. That's something that he needs to find out. Yes, so that is something that we cannot improve on. Again, with 1,000 books, that does not is an issue. With 10 million books, it is an issue. Next, I'm going also to implement the ESBN, and then we can see if this works, and then we can test the whole thing. I guess by now you know what you have to do for this, the query on a book number, because it is more or less the same then starting with an A. So but I'm going to show you one other thing. So we again get all the books, we stream them, we filter them on book is equals to that book number. Actually, that is a question for tomorrow, but what is best, find any or find first? I'm going to cover Java 8 streams more in detail tomorrow, but I can, because I'm here now, I find any and find first. Find first is the best according to someone. Anyone another opinion? We have two for first. Actually, find any is more performant. Because if you say find first, it needs to take into account if that stream is ordered yes or no. And if it is ordered, he needs to respect that order. So find any, because yeah, ESBN, or it should be in our case, so that's the rest of the code that needs to make sure that there is only one book with that book number that we are looking for, or no book at all. That's also possible, of course. So if we find a book that is matching that number, we have found what we are needing. So we don't need the first one. Most of the time, the first and the any will be comparable, but not if you do, for instance, parallel streams. Because if you do find first with a parallel stream, you kill your performance, because you're basically saying, oh, I'm doing parallel, but I'm not allowed to do parallel because I need to do a sequential read. So find any is something that I always use. I never use find first, especially not when you are searching for something unique like a number. No, it's not like this. If we don't have a if you don't have a book, then but that depends on the framework that you're using. We should throw a 404 as a result, because yeah, that URL does not exist. So we have to do it in like something like this. I'm not good in typing for the moment. Sorry for that, guys. So this should give us the book number, and then we can see if it works or not, what we have written. Maven clean package. And start it up. Not. Okay, because I thought that I saved. Yeah, I have my ISBN number there. Okay. Yeah, I just inherited this course last week, so, and I changed it a bit, so not fluent in it. Sorry for that. We have our books again, so if we go here, we can get all the books. There they are, all the books. We can create a single book. Yeah, it does not, because it is successfully created. If we do then the ISBN number, I think it was 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me check again what we have created here. Yes, then we should receive that single book with the name single book. And it does not find it, so I have made a mistake. So I will find it out during the break that we are doing. And does that work with a start with an A? There it works. There we have a book, All the Pretty Horses, Almania, etc., etc. So they all start with an A. So that's good. I only have to check why that book one, that search on the ISBN number did not work. Update a single book. So, yeah, okay. Hopefully it is there. Oh yeah, I didn't. I need to specify it as a query parameter. Sorry, it's ISBN 2, 3. Okay, I'll have a look why it doesn't work. Yeah, clear is just we did it here also. Clear your entire set and then save all. Save them all again. Sorry, here save the entire list. But how do we update? So we have an update. We, for instance, we get that book with that single ISBN number. So we should have one. If we don't have it, then again, we can throw that exception. I try to copy it, but probably it's as fast as just typing it over again. Status not found. So we have now a book, and we change the name to the real book name, because I remember, yeah, we just put it here, something like single book. But what if we want to give it a real name? Someone who wants to try what I need to store?
Or just the book instance?
Yep. I think you're, but yeah, you mentioned that this morning, that you were already a bit playing, no?
Yeah, a little bit.
Yeah, so change what is store what is changed, not change what is stored. This means we just change the name, and this is an error that I make more than once. You need to actually store the reference and not the optional one, because otherwise, of course, it tries to store the optional. We only changed this book, the name of the book, which was already in the database. So the book is okay, is already known by MicroStream. So we only need to store the book itself, which means that it stores the new name and nothing else.
So just to make myself clear, if we want to insert new one, then we need to store whole list.
Yeah.
But if we want to change or update something, then we just need to store that specific object.
Correct. Completely 100% correct. It takes a bit to get that mindset. What is now actually changed? You more or less can see what you're accessing and changing. You see, I do here an at all, so that's a change operation on what? On books. So make sure that you store the books. I do here a where is it? I do here a set name on that book.get. So pass that book.get to the store method. Most of the time, that trick will be the correct one. And if you have multiple things, then you just put multiple things. But then there is something better, because probably you want to update multiple books, and I will copy it again. Let's say that we are giving a discount. I think it was, if I look at the solution, it will be something else. But suppose that we want to lower the price of all the books that start with an A. I'm going to use a for loop. I can do it also with the stream, but sometimes for loop is. So I'm going to change the price, saying that it is the original price times 0.9. I will not do it because it is a big decimal, so multiply with big decimal value of 0.9. So I give 10% discount. Do I do a store like this? Or should I do something else?
I think in this case, most efficient call should be passing complete list to store again. After the for loop.
Actually, that will store nothing.
Okay.
Because the pointers within the list, in this list, are not changed. It are the objects within the items. It is tricky, but please, if you have time today or tomorrow, play with it, and then you probably will. I hope that I'm right, because I did not try it out myself, but storing the entire list will not have this discounting effect, because you will store the changes within the list, and this is not a change within the list, but it is in a change within the POJOs of that list, which is not the same. But it is a good question. Probably not by efficiency, but there is something else that what happens. What happens if I'm changing 100 books, and after 50 books, my system crashes? How many books will be changed in the storage? 0, 50, or
50.
50? Correct.
So
this
sorry.
is, as I said, we don't have transactional. This is not the all or nothing. Probably what you want is that if you call this method, if it's successful, then of course everything is changed in the database, in the storage in our case. But if it fails for some reason in between, then it should be no operation at all. We should not store partially updated data. That's most of the time the case that we want. If not, then of course, then this does not apply. So this store already stores the first book, the second one, etc. So if it crashes after the 50th update, only those 50 are in and are already in, and not number 51, etc. So it's not the all or nothing principle. Although I said that there was a it is on the, we always use the lazy storer, but we can also access the lazy storer itself. And this has an advantage in the sense that that's the one that I need at the end. I can store each book. And then at the end, I can say, do all the commits. Because actually, and that's something new, but I do it step by step. This store is doing a two-step process. It first generates the binary representation of your object, and in a second step, it does a commit, meaning it writes it to the external location. And I know it's a bit confusing, but this store from the lazy storer, or also the eager storer, so if you ask for an eager storer, it is the same. This store creates the binary representation, but does not do the commit. It only does the commit when I explicitly ask for it. So by using this construct, I am 100% sure that either all info is saved to the storage or non-info at all. So if it crashes here in between after book 51 of the 100 books, then nothing will be stored. That's something that you need to know. And my first example that I created with eager storer, and I used it like this. And then I went back to the developer saying, eager storer does not work at all. It does not store anything. What's going on? What major bug do we have? And then they said, oh, you made stupid between brackets error, that is, you forgot to commit. Yep, go ahead if you have a question.
So do you have a rollback on this API as well? on lazy storer, do you have rollback call as well, or would just discard the object and garbage?
Yeah, as I mentioned, there is some kind of rollback by retrieving the values from storage again, but that's not an one-line API. So that's something for the advanced one. But yeah, indeed, you could have something here in an exception block that says undo these changes by loading the list again or something.
So this lazy storer, is it a singleton object across the JVM, or when we say create lazy storer, it create a new object and give reference back?
Good point. I have to check. I'll have to make a note to check it out, because I don't know exactly the but that's also related to concurrency and using it from multiple threads at the same time, which you should avoid. So that's part of the advanced course also, but I can have a look to see if this is a singleton, yes or no. Okay, you will have the opportunity to play around with an example after the break. I will explain then what the ideas of the exercise is. And then, of course, you can still ask as many questions as you would like. But these are the basic concepts that I said this morning. Create a storage manager, reading from the data, changing the data, and making sure that it is stored again. This is basic MicroStream, what the fundamentals that you need to know. Tomorrow are a bit few side things around that, which are also important, but today we covered the entire basic flow of the fundamentals one. Yeah, and I had time for a break now. So 5 minutes after the, I'm on, unless someone is on a half an hour difference, which is also possible. So, but so in 10 minutes or 11 minutes, we start again. So welcome back, everyone, for those who were away from the keyboard. Yeah, the error that I made was that, okay, I needed to specify it as a query parameter, value equals 1, 2, 3, 4, 5, 6, and 9, and then I get that additional book that we added. So there was nothing wrong with the code, just there was an error in me retrieving that that info. There is the question, what's the use case for the lazy storer? Not sure that that you mean the lazy storer or the eager storer, because but both lazy and eager storer, you can use it here to have a all or nothing solution, so that you don't store a partial update, so that if you say 10% discount for all the books that start with an A, that you don't end up with some books where you have applied it and some books where you did not have done it. But the main difference between then the lazy and the eager one is that, as I said in the beginning, the lazy one stops whenever it encounters a unchanged pointer, like here. So it does not see the changes here from 9 to 4, which the eager would store, because the eager just starts from the beginning and stores everything again. So maybe the question is, what's the use case of an eager storer? That's very limited, and only in some cases it can be easier to just say store me this subgraph, because there are random changes at places, but it was too difficult, or it is maybe too difficult to track them all individually, and that you just store an entire subgraph, because both the lazy and the eager storer works also on subgraphs, that you use that, but most of the time you use the lazy storer. That's the most efficient one. Yeah, so as I mentioned, don't forget to commit the one and to send multiple changes. Yeah, so the three main rules for to store. So if you add or remove an item from a collection, a list, map, or whatever, then store the entire collection. If you add, for instance, a new key in the map, for instance, that's also an entire change of a collection. You have to store the map. If you update a property within a POJO, like we did with that book, update the name of the book, then you just store the POJO itself. Maybe you're tempted to say, well, I do always store me the collection because that's easier. But as I said, you will not store changes in the POJO when you say store me the collection, because it does not see it unless you are using the eager storer. It is a bit helpful because if you say that a object is final, is immutable, like I did here, then you help MicroStream that you know that, or that he knows that this reference will never change. So he doesn't need to take into account that there might be a change of the list itself. So that helps it a bit, but again, you see that here only one reference, so that does not make any, well, not any real difference, but in a larger set, it is always a good idea to declare your collections as final and initialize it with an empty set or an empty list here, like I did here. That will help a little bit for the MicroStream algorithm. One thing you need to know if you're running in a container, that the serialized format before it is stored externally is stored off heap in native memory. So that's important to design the size of your containers, the memory requirements, because a lot of people make the mistake, and that's not only for MicroStream, but in general, that oh, I need 256 megabyte of heap, so I start up a container with 256 megabyte of RAM. Eventually, that container will blow up, saying it is a kind of out of memory error or something, I guess, because also pure the JVM itself, but also here then this store method, they use memory in addition to the heap memory. So besides the heap, the JVM is also using other memory from your laptop, your container, or whatever, on top of what you define as a as heap memory. So that's that can sometimes be a bit difficult and frustrating, that you always design your JVM in sizes of the JVM heap, but that's not the total heap that your JVM needs. So you always need thumb of rule is 10 to 15% more, but if you are storing a very large tree, if you store a lot at once, then that can be a substantial amount of size of that off-heap native memory that is used in addition to the JVM. So be aware of that, especially in those containerized environments.
Can we configure the maximum heap size maximum off heap size of MicroStreams?
No, you cannot configure that because it just takes what it needs. So if you, for instance, load a list of 100 megabytes, I'm just saying something, then to serialize that, he needs that also roughly the same amount of heap native memory on top of that. So yeah, be aware of that before the commit, everything goes to native memory of heap. So if you're putting very large things at once, then you can have the issue that your off heap memory grows so large that you also have issues. Questions, or can I explain the idea of the exercise that you can do on your own? We discuss it tomorrow morning, of course. And if you have questions between now and the next 45 minutes, the official end of the training, then of course you can always ask me. I will be here. But to close this day, I've prepared an exercise. Unless there are now still any questions.
So I tried the simple example and used Java 17, and there was an illegal access to Java JDK unsafe or Java misc unsafe. Is this expected behavior or is it a bug?
Here on the simple config.
Yeah, well, I recreated it, but yes. Basically just started up the most simple example with
I did
17
on 17, if I'm not mistaken. To be 100% sure, I'm going to delete this.
Did you add some kind of framework? Might be
No.
I getting.
No frameworks, just the pure MicroStreams, just the main class, nothing else.
And it is not using the module path system, huh? Just
not yet.
class path,
that is another question.
Yeah, because with the module path, there we might have issues, or we can have issues depending on how you configure it and how you open up modules, etc. Especially if your data is in another module than your code, etc.
Try to paste the trace.
Okay, sorry, still running 11 because it was already here. I changed it there, but it's still here. So if I run on 17, that's a simple one. I'm running it on Zulu 17 without any issues. So that's something then we need to look more into detail why it does not work.
Yeah, maybe we can look later at that.
It might be the JDK. With OpenJDK, it works. OpenJDK 17.
Interesting. I'm using the Microsoft JDK, so maybe that's the issue. But
okay. The Azul one works, the OpenJDK one works, so then the Microsoft not. Okay, that's interesting.
maybe it's an issue on my part. Who knows?
So in that basic training GitHub repo, there is here an exercise.md, a markdown file. So the idea is that we have a car company and we have entities like car and brand. So the example that we touched more or less this morning when we discussed the data model. And yeah, so the idea is that you have your root object is in a car company. You have a list of cars, and each car has a brand, and you also have a list of brands, and you perform a list, get, delete, and insert on the car, and list, insert, and update on the brand. And you change if you are using the templates, which is fine. That's the reason why I created those templates, so that you can get started faster and don't need to set up your runtime or your application with all the details. But that template uses the configuration within code, programmatic configuration. So use also a properties or XML file. And of course, you are free to use any other example, copy and paste. That's the life of a developer, copy and paste, as long as you know what you're doing. And that's fine for me.